types of prisms, they all have one thing in common, and that's how you define a prism. So a prism is defined as a solid that has two bases that are congruent, and that's the important part, that are congruent and parallel. And so the very first thing we're going to start with is, how do you name a prism? And the way you name them is depending on their base, that's what you're going to call it. For example, if the base of the prism is a rectangle, then it's a rectangular prism. If the base of a prism is a triangle, then it's going to be a triangular prism, such and such. And so if we look at the very first one, we have the base here, which is a rectangle, and the other base that's opposite, congruent and parallel to it, is also a rectangle. And so here we have what we call a rectangular prism. And same for the next figure. So the next prism, the base shape is a triangle, and we know that it's the base because it's only two of a kind. For example, it's not the rectangle. It's not, here, let me see if I can, it's not this part right here, because if you notice, there's three of them, not just two. And so here, because the base is indeed a triangle, then this is what we call a triangular prism. And same with this last prism down here, the base is a trapezoid, and so the name for this prism is a trapezoidal prism. So now let's talk about, we have different parts of a prism. So we have what we call lateral area, and then we have something that we call total surface area. And so let's start with lateral area. So lateral area, if you think back to nets, lateral area is kind of like everything except the base. So for example, if I define in this rectangular prism, okay, if I define this to be my base, right? So here's one base, here's the second base. Then what's going to be considered the lateral is everything else. So we have this top rectangle up here. We have this side one down here. Then we have this one in the back, and this bottom one down here. And so that's what we call my lateral area. And so for my lateral area, yes, we can find the area of this side here, the back one, the top one, and the bottom one, add them together. Or if you think about it, if I can kind of extend all of this, if I can kind of extend, in other words, if I can kind of make the net for this, the net might look something like this, where this is one of the base. Okay, so we'll say that's the base. And then we have the bottom, which is down here at the bottom. And then I'm going to draw this other base right there. So that's kind of like the whole bottom part. And so the next thing I'm going to draw is draw the two sides. So here's one of the sides, here's the other side. I'm going to erase this part. So these are the two sides, and then we got the top. So which is, so let's just call it this. And so I know it's kind of sloppy, but there's a point to this, I promise. If you notice, once I kind of lay it out, I have a big rectangle here. And so, yeah, so what I was saying is, yes, we can find the area of this, each one individually, add them together, and that's going to give me my lateral area. But the fastest way, or the quickest way to find lateral area is to find the perimeter, okay, of one of the bases, and multiply that times the height of the prism. And the reason we're going to do that is because if you can see, so if I were to fold my net, or if I were to fold this figure, this side would match up here, this would match with the top, and this would be here. And so that, and then the bottom one obviously is just the bottom one. And so that kind of outlines the perimeter of the base, so that's why we got to find the perimeter. And once we have the perimeter, the only thing that's left to do is multiply it times the height of the prism, which is the height is going to be of the prism is going to be defined as the distance from one base to the next. And so to find lateral area, and we're going to use LA for it. So lateral area is just going to be the perimeter of the prism times height of the prism. So here I'll put P is the perimeter of the base, and we said H was going to be height of the prism. And so this formula here is, no matter what the shape is, it's always going to give me my lateral area. Okay, so and then one thing that's good about this is perimeter for any area or any shape, you always just add up all the sides. So if it was a triangle, you add up all the sides. If it was a parallelogram, add up all the sides. If it was a trapezoid, add up all the sides. Hexagon, any regular polygon, you just add up all the sides. And then the height of the prism is just the distance from one base to the other base. Okay. And so now let's talk about total surface area, which we're going to define as SA. So total surface area, well, one is going to include my lateral area, so put LA, plus, so if I'm looking for the total surface area, that means I'm looking for all the areas, which includes the lateral area and the area of the bases. And so here, the lateral area gives me everything around except the bases. And so really the only thing that's missing from my total surface area is the area of the two bases. And so because we know the bases are congruent and parallel, then really all I have to do is find the area of one of the bases and multiply by 2 because I have two bases. And so down here, LA, we already said it's perimeter times height. And B is going to represent the area. So I'll write it down. B is equal to area of the base. If you stick with me, we're going to do some problems in a bit. And so I'm going to rewrite this equation one more time with everything we know. So LA, or lateral area, we said was perimeter of the base times height of the prism plus 2 times area of the base. Okay, so these are the two formulas that's going to be important for us once we start doing some of these problems. So we got this, which is my surface area, or you can label it as this, doesn't matter, you get the same thing. And so we have our two equations. Talk about the actual formulas for a rectangular prism, triangular prism, and trapezoidal prism, and then we'll do some examples. So starting off with the rectangular prism, we have the base being a rectangle. And so I have my lateral area, which is just perimeter times h, where h is going to be height of the prism, which is going to be the distance from one base to the other base. And then we have my total surface area, which is my lateral area plus area of the two bases. So now, because the area of a base, or which is an area of a rectangle, is just base times height, we have to be a little bit careful with our wording. So here, my lateral area was perimeter times height. My area of the base is length times width, or base times height, however you want to say. But we have to be careful because this B represents area of the base. For a triangular prism, we have the base as a triangle, and so that's going to change how we write the formula for surface area. For lateral area, it's just perimeter times height. Now, here's one disclaimer. Remember, height is not the height of the base. It's the height from one base to the other base. Now, when we're finding perimeter, sometimes you're going to be given the height of the base or the height of the triangle, and we're going to have to use Pythagorean theorem to find some of these sites, and we'll do some of those problems at a later video. For right now, my total surface area would be lateral area plus 2 times the base. And so if we write it one more time, we have perimeter times height plus 2 times area of the base. Now, because the area of the base is a triangle, the formula that I would use to find the area of a triangle is 1/2 little b for base times h for height. Now, here's where we have to be careful because, once again, that little b represents base of triangle, or kind of like the base of the base, so this base down here. And this little h here represents height of triangle. So this height right here, and it does not represent the height of the prism, it represents the height of the base. And so that's why we say we got to be a little bit careful, okay? So these two h's, these two heights are different. I'll put difference.